And these trabecular patterns will form along stress lines. So if we look at the head of the femur, or the part of your femur that's close up to your hip, we can actually very well see in a coronal plane cross section. So if we take your femur and we kind of cut it in half, we can actually see these stress lines forming. And these stress lines form as a higher density of these lines of trabeculae to mitigate and absorb the forces associated with impacts such as our sporting activities, jumping, walking, running, etc. And these sporting activities will induce a quote unquote strain. So our bones are not completely rigid structures, but they actually bend and twist minuscule amounts as we do things like run and jump and do all of these activities. And this is important because if our bones weren't somewhat malleable, then they would be much more associated with fractures, or much more likely to fracture, because they would be very brittle. It's kind of like the piece of chalk that if you accidentally drop it on the floor, it might fracture into multiple pieces. And that's because chalk is itself very, very brittle. However, if we took something that was much more malleable, like silly putty or something like that, and we dropped that on the floor, it would just deform based on the amount of stress that's applied to it. So this is all to say that bone is a very dynamic structure, and the dynamic aspects of bone can also be mediated by the activity of specialized bone cells that are very important for remodeling and modeling bone.